Hello dear students. So in this video we will going to discuss methods of analysis of determinate truss. So we know the determinate and stable truss can be analyzed by using method of joints and method of section. So important is method of joint and method of section, and another two methods are graphical method and bar chain method are also there. So but in our syllabus we will discuss only method of joints and method of section to analyze our determinate truss. So what is method of joints? So in the method of joint, we need to find the forces in all members, and in this method, equilibrium of each joint is considered, and we know at each joint two equations of equilibrium are available. That is summation of fx0 or summation of fy0. Okay, so if you see this figure 3.5, then this is your hinge support, and two reactions are acting. One is horizontal HA, and another is vertical RA. This is RA, and at this roller support, and one vertical reaction RC is here. Okay, and these are the two external loads which are acting on the joints or nodes on the truss. Okay, so W1 and W2 are the external loads, and this is your compression. Okay, and the arrows are indicating towards each other, and this is your tension. Okay, and the arrows are indicating away from each other. Okay, and in the method of joint, the one important thing is only two equations of equilibrium available at each joint. That is, at this joint, two equations of equilibrium available. Summation of fx is equal to 0 and summation of fy is equal to 0. And one more important thing is this this method cannot be applicable when number of unknowns at each joint are more than two. Okay, so this is a joint, and if we are having a number of unknowns more than two, then this method is not applicable. Okay, so we need to find only two unknown forces to calculate this type of analysis by method of joints. So in this method, the selection of joint is very important. Okay, and after that, proceeding one joint to another, that number of unknown forces at the joint are not more than two. Okay, so by sign convention, we know the compression is for negative and the tension is for positive. Okay, and also tensile force is positive and compressive force is negative. And what is the procedure to check for static indeterminacy? We first determine our static indeterminacy for your truss. That is, ds is equal to m plus re minus 2j for 2d truss, and ds is equal to m plus re minus 3j for 3d truss. And in our syllabus, the truss is determinate only, and it is stable. So such trusses are called the pin jointed perfect frame. And for the process, the external support reactions, we know it can be found by using conditions of equilibrium like summation of fx0, summation of fy0, and summation of mz0. Okay, so and after that, step 2 is draw the free body diagram of that joint at which only two unknown forces are present. Okay, so this is important. Free body diagram of that joint, only two unknown forces are present. Now consider equilibrium of joint and apply conditions of equilibrium to find unknown, that is summation of fx0 and summation of fy0. And by the similar way, we can proceed to another joints one by one at which only two unknown forces are present, and use our conditions of equilibrium to find the unknowns. Okay, so let's quickly solve some examples on method of joint. So find the forces in all members of truss using method of joint. And this is a truss, and it is a hinge support here, and horizontal reaction here, one horizontal reaction, one vertical reaction RM. This is a roller support, and our reaction is having RB here. Once roller support is having only one vertical reaction. Okay, and this is your C joint, and W load is acting over it, and the distance of this CD number is A, and AD is A again, DB is A. Okay, so we need to find our DS value. So DS value is 0 here. Okay, DS is equal to m plus RE minus 2j. So it is a determinate truss. And after that, we need to determine our support reactions by taking our three equations, that is summation of fx0, summation of fy0, summation of mz0. So to determine your Ra and Rb, what we need to do, summation of fx is equal to 0. So summation of fx is equal to 0, ha is equal to 0 because we are not having any horizontal force here. So ha is equal to 0. So this is ha is equal to 0, and summation of fy is equal to 0 means Ra plus Rb is equal to W. Okay, so this is our first equation. And if I'm taking this hinge support and summation of all the moments at the support is 0, so RB into A plus A, that is 2A, minus W into A is equal to 0. So RB into 2A minus W into A is equal to 0. So here RB is equal to W by 2, and from first equation RA is equal to W by 2. Okay, so we are having RA and RB value. Now we need to find our forces in every members. So method of joint, we are considering joint A here, and C here is at this joint we are having only two unknowns, that is force in member AC and force in member AD. So we know by convention that at every joint the number of unknown forces are not more than two. Okay, then the joint will be selected. So here we are having only two unknowns, that is AC and AD. So consider joint A of equilibrium, and we are here. You can see the free body diagram of joint A. Here we are having a W by 2, and this is a force in member AD, force in member AC, and this is our angle 45 degree, because we know this is a right angle triangle, and here 90 degree. This is 45 and 45. So this is a 45 degree, and summation of fx by resolving this inclined member, that is force in AC, in two parts, dissolve it in FAC sine theta in verticals and FAC cos theta in horizontal. So summation of fx is equal to 0 means FAD, this is a horizontal part, plus one component of this FAC. So one FAC cos 45 is here. Okay, so FAC cos 45 plus FAD is equal to 0, and from here FAD is equal to W by 2. So if it is your equation 1, then summation of Fy is equal to 0 means W by 2 plus FAC sine 45, because we are having one another component of FAC sine 45 in y direction. So W by 2 FAC sine 45 is equal to 0. Here we are getting FAC is equal to minus W by root 2, and by putting this FAC value in this equation, so FAD is equal to W by 2 here. Okay, so if we are having a positive value, then it is your tension, and if we are having negative sign, then it is our compression. Okay, so move on to the next joint, that is joint D. So this is a joint D, and draw the free body diagram of the joint, and we know the member AD is having a W by 2 plus value, and FDB is your unknown value, and FDC is your unknown value. If I'm considering summation of Fx0, so FDB is equal to W by 2. So this is FDB force, and summation of Fy is equal to 0 means FDC is equal to 0, because it is not having any vertical force here. Okay, so FDC is equal to 0. Now consider our joint B again. Now this is a joint B, and we are having angle theta here again. So this is a free body diagram of joint D, and this is a 45 degree, and this is a member FBC. Again we are having a component of FBC sine theta, and FBC sine 45 and FBC cos 45. Okay, so for a summation of Fx is equal to 0, we know the W by 2 is in x direction, plus the component of this FBC is FBC sine 45, which is equal to 0. So FBC is equal to minus W by root 2 in compression. And again for joint B, we are having FBC is equal to minus W by root 2, and in compression, because we are having a negative sign. So by this way you can find all the member forces in the truss BC, DC, DB, and AC and AD. Okay, so this is our question simple. Now move on to the next question. Consider a loaded truss shown in the given figure, and match list members and list to force and select the correct answer. So this is your truss again. This is a roller support. We are having one vertical reaction, and we are having one horizontal reaction and one vertical reaction here. Okay, and this is our distance H. External load is 60 kilonewton, 30 kilonewton. So we need to determine whether it is a stable or determinate truss or not. So ds is equal to m plus ra minus 2j. So by this ds is equal to 0, and we need to find our external support reactions. So support reaction, this is rp plus rq is equal to 60 plus 30. Okay, and horizontal part is 0. We know that we are not having any horizontal reaction, so HQ is equal to 0. Okay, so RP plus RQ is equal to 60 plus 30, that is 90. And by summation of moment at the Q, at this is a hinge support. We are having summation of all the moments at this support is 0. So by taking moment, that is Rp into H plus H, that is Rp into 3H minus 60 into 2H minus 60 30 into H. Okay, so this is our equation. Rp into 3H minus 60 into 2H minus 30 into H. Okay, by taking it in your RHS side equal to part. Okay, so it is positive here. Now by solving this, Rp is equal to 50 kilonewton, and from this first equation, Rq is equal to 40 kilonewton. Now do our method of joint part. Now take our joint P here. Okay, and we are having the consider summation of Fx0 and Fy0. Draw the free body diagram at joint P. So we know we are having a 45-degree angle, and this is our FPR here. So this is a force in PR, this is a force in PT, and the uh, FPR. So the horizontal part is your FPR cos 45 degree, and your vertical part is FPR sin 45 degree. Okay. So summation of Fx0 means summation of FPR cos 45 plus FPT is equal to 0. This is our first equation, and for vertical summation of Fy is equal to 0 means 50 plus FPR sin 45 is equal to 0. From here, FPR is equal to minus 50 kilonewton. And by putting the value of FPR in this equation, we get the value of FPT, that is minus FPR upon root 2. So this is minus. So we are having a compression here. And from equation first, FPT is equal to plus, that is a tension. Now consider a joint T. This is a joint T. Okay, now draw the free body diagram of the joint. This is a 50 kilonewton here. FPT is 50 kilonewton, and your 60 kilonewton external load is acting here, and we are having two unknown joint more forces here, FTR and FTU. So summation of Fx is equal to 0 means FTU is equal to 50 kilonewton directly, and FTR is equal to 60 kilonewton by summation of Fy is equal to 0. So both are positive, so it is in tension. So consider a joint Q here. So draw free body diagram of joint Q again, and this is our inclined part, and we are having two components again, FQS cos 45 and FQS sin 45. Okay, so summation of Fx is equal to 0, so FQU plus FQS cos 45 degree is equal to 0. This is the first equation, and for summation of Fy is equal to 0 means 40 plus FQS sin 45 degree is equal to 0. So by here FQS is equal to minus 40 root 2 kilonewton, as minus sign here, so it is in compression. By putting FQS value here, we get the value of FQU is equal to minus FQS upon root 2. Okay, so FQU is equal to 40 kilonewton. So by this way, you can solve all the forces in the all the forces members in the truss. So now consider joint S again. So this is your joint S here. Okay, and draw the free body diagram of this joint. So this is your FSR member here, and this is your FSU. This we know the value of this QS is your 40 root 2. We already calculated here. So minus 40 root 2, so it is minus compression. Okay, so summation of Fx is equal to 0. We again summation of FSR plus 40 root 2 sine 45 degree is equal to 0. Okay, so this is a horizontal part, and the component of this FSQ is equal to 40 root 2 sin 45. Again, FSR is equal to minus 40 here, and for summation of Fy is equal to 0. So FSU is equal to 40 root 2 cos 45 degree. Okay, so for vertical part is uh, 40 root 2 cos 45 degree. So from here, FSU is equal to 40 kilonewton. So by this way, you can calculate all the member forces in the truss. Okay, so this is our last question of method of joints here. So thank you so much for watching this video.